In this session, we are going to discuss about concentration terms. So, what are concentration terms? Right. So, there are a lot of concentration terms are there. Pa. So, we used to measure distance in a lot of units: meter, kilometer, centimeter, mile. So, depending upon our requirement, we use different units, right? Similarly, concentration maaro. Consider a container having a example water. Now I am adding 1 spoon of sugar, another container of water with 3 spoons of sugar. What is the difference between the two containers? Sir, the concentration of sugar is less, whereas the concentration of sugar is more. That is the difference. Both of them are sugar solutions, but the difference is in concentration. So students used to feel a lot of difficulties in expressing or understanding this concentration terms. That's the main problem in case of students because of lack in understanding. If you understand the things properly, then it will be very easy for you. In this session, I'm going to discuss about the concentration terms in short. Okay, right. The first concentration term is molality, which we are going to see. The second one is normality. The third one is molality. First, I will discuss about these three in detail. Right. The symbol for molarity. Oh, I've written it wrong. Molarity. Okay. The symbol for molarity is capital M. Molality is small m. Normality is capital N. Right. Sir, I have a lot of confusion regarding these three. What is molarity? Abdinaka? Nothing but number of moles of solute in 1 liter solution. I'll simply say this as moles per liter of solution. That's it. This is expanded like this: number of moles of solute by volume of solution in liters. Right. Next, normality na sir? What is normality, sir? Number of gram equivalents of solute in 1 liter solution. Sir, I cannot understand. Number of gram equivalents per liter. This is the simple word which is expanded like this. Sir, gram equivalents, and I will explain. Don't worry, I will explain. Sir, what is molality? Small m abdinaka. Number of moles of solute. Number of moles of solute in 1 kilogram solvent. இதுதான் இங்கே ரொம்ப முக்கியம். ஓகேவா? So the unit expression term for this is moles per kilogram of solvent. Moles per kilogram of solvent. Let me express this in a different way. Formula பாருங்க. Capital M molarity is equal to number of moles of solute by volume of solution in liters. Generally, there will be two substances in any solution, minimum two substances, that is called as binary solution. The one which is present in excess amount is called as solvent, and it is denoted as 1 or capital letter A. The one which is present in minimum amount is called as solute. It is denoted as 2 or capital letter B. So 1 refers solvent, 2 refers solute. So the numerator should be solute. We are discussing about the sugar present inside water, not about water. Sugar is important, solute is important. So it is number of moles of solute done to by volume of solution in liters. Normality என்ன formula? Sir, number of equivalents of solute by volume of solution in liters. Molality என்ன formula? Number of moles of solute by weight of solvent in kilograms. Right. What is the formula for number of moles? Sir, number of moles na weight by molecular weight. This is the formula for number of moles. And in general, volume is expressed in milliliter. If you change liter to milliliter, now what should the conversion? Sir, divided by 1000 is the conversion. Denominator's denominator, it goes to the numerator. So it comes here. Similarly, look here. It is weight by equivalent weight. Number of equivalents na weight by equivalent weight. Number of equivalents na weight by equivalent weight into volume in milliliters is expressed. So that means 1000, and comes here weight by molecular weight into weight of solvent in grams. If you say in grams, there should be 1000 in the numerator. That's it. So these are the formulas. Okay, from these formulas I am going to deduce 3 other formulas. I'm going to keep this W2 this side and take the remaining two things to the left hand side. What will be the formula? W2 is equal to capital M, molarity, M2, molecular weight of solute, volume by 1000. Similarly here, W2 is equal to, so W2 is equal to normality into equivalent weight of solute into volume in milliliter divided by 1000. Here, what is the formula here? Sir, W2 is equal to molality into molecular weight of solute into weight of solvent in grams divided by 1000. So these are 3 very important formulas. Okay, ma? Now, in order to understand the next thing, we need to know next topic. That is nothing but, one is called as weight fraction or mass fraction. It is also represented as W by W percentage. The next one is called as volume fraction, which is denoted as V by V percentage. The third one is called as weight by volume fraction, which is denoted as W by V percentage. W by V percentage. Sir, what is W by W percentage? What is V by V percentage? And what is W by V percentage? Nothing but W by W. That means weight by weight. Weight of whom by weight of whom? Weight of solute by weight of solution into 100. V by V means volume of solute by volume of solution into 100. Weight by volume means the numerator of the first case divided by the denominator of the second case. Denominator of the second case into 100. So, this is the third case. This is the symbols are the weight of solute. Solute nale 2. Solvent na 1. By weight of solution into 100. This is volume of solute by volume of solution into 100. This is weight of solute by volume of solution into 100. So these are 3 different formulas. I'm going to use this formula above. How, sir? Look at the screen carefully. I will explain how. Look here. W2 into 100 by V is called W2 into 100 by V is called W by W percentage. W by W percentage. Instead of writing like this, I can write W by V percentage. So it is W by V percentage into 10 divided by M2. Similarly, look here. W2 into 100 by V. So I can write the formula. Normality is equal to W by V percentage into 10 divided by E2, equivalent weight. Here we cannot write like that because denominator is not W solution or volume solution. Denominator is volume of weight of solvent. So we cannot use like that. Next important thing. What is the formula for density? Sir, density na weight by volume. So volume to the left, W by density. I am going to use this here. So parang enna nadakudhu, what will be the change? Sir, capital M molarity is equal to W2 into 1000 by M2 into, instead of volume, I can write weight of solution into density of solution. Similarly, this volume can be rewritten. I can write normality is equal to W2 into 1000 divided by, so paranga W2 by 1000, W2 into 1000 by equivalent weight into weight of solution into density of solution. Right, next. Now look at the formula. W into 100 by W. This is nothing but this. Similar, W into 100 by W. This is nothing but the same. So what can I do now? Instead of, W2 into 100 by this. W2 into 100 by this. Instead of this, I can write W by W percentage into 10 into density of solution divided by molecular weight. I can write W by W percentage into W by W percentage into 10 into density of solution by equivalent weight. Okay, va? So these are the very important formulas which we have to understand or keep it in mind for our better knowledge. Without these things or without understanding this properly, you cannot work out questions relating to this molality or something like that. Okay, va? Right. Next. இதில் இன்னும் ஒன்று இருக்குது. என்ன சார் அது அப்படின்னாக்கா, that is nothing but the mole fraction and parts per million. Parts per million. Sir, what is meant by parts per million? Look at the screen carefully. Parts per million. You can use any of the above three formulas. You can use this or this or this. 99% this will be used. Weight by volume will be used. Instead of 100, it is converted into million parts. 10 power 6 into 10 power 6. So you can use in general any of the above formula. Generally, weight of solute by volume of solution into 10 power 6. Then there is another term called as mole fraction. Mole fraction. Sir, mole fraction symbol psi. What is psi, sir? For a binary solution. What is meant by binary solution? There are two components, A and B. A is called, as I already told you, A is solvent. B is solute. Mole fraction of A moles fraction of A by total. Total moles that is nothing but the number of moles of A plus number of moles of B. Similarly, mole fraction of B number of moles of B by number of moles of A plus number of moles of B in total. Since it is a binary substance, if you add the mole fraction of the two components, it will be equal to 1. If it is a trinary substance, there are three components. Now if you add all the three, it will be 1. Okay, so depending upon the number of components present, the mole fraction varies. And that's it in this video. We'll see you in the next session. Thank you.